Good morning, everybody. We are working in now chapter 14. Chapter 14 is going to deal with a lot of trig stuff, so sine, cosine, tangent, angle measures, all those different types of things. So we're going to start with kind of the basics today, some basic terminology, degree measure, standard position, and then coterminal angles. So a lot of terminology here to kind of start out with, and some basic terminology that we're just going to kind of discuss as we go through. So basic terminology, 2 points determine a line. You know that, so this is line AB. A little bit of geometry review right now, terminology you've heard before. So that's called line AB. A line segment, AB is a portion of a line, so it's just a little piece of it. We call that line segment, AB. And then a ray is a proportion of a line that starts at A and continues on and past B. So that's called a ray. So we've got a line segment, and a ray. We're going to use rays a lot. Obviously, rays make up angles, so we'll be talking a lot with rays today. An angle consists of two rays. And again, you've looked at angles before. Two rays in a plane with a common endpoint. We call that common endpoint the vertex. So that part right there is called the vertex of the angle. That's where the angles meet. We want to find degree measure. We find the measure of that angle kind of right in there. Two rays are called the sides. Common endpoint is called the vertex. And that's the angle measure. We can get that angle measure by rotating about the vertex. So that angle measure can actually change, and that's what's going to happen a lot in the stuff that we do today, is that angle measure itself is going to change. And we're actually going to work on rotating it around the coordinate plane. Okay, so there's two sides. Obviously it has two sides. The initial side is kind of where it starts opening, and then where it ends opening is called the terminal side. It's where it ends. So a ray in its initial position is called the initial side. A ray located after the rotation is called the terminal side. So you've got an initial side, it opens up, and you've got this terminal side is kind of where it ends. Terminal means to end, so that's the terminal side. Angles can go in two directions. You can either have positive. If you go counterclockwise from an initial position, that's a positive angle, or you can have a negative angle. A negative angle goes clockwise from the initial position. And again, we've got an initial side here and a terminal side here. We've got an initial side here, and we've got a terminal side here. And actually, we would find an angle measure here. This may be something like negative 50 or something like that, and this may be positive 300 degrees. Nice 300. But that might be something like positive 300 degrees. We can find those angle measures, or we could simply do some subtracting as well. But just note that if you go counterclockwise, that's a positive angle. If you go clockwise, it is a negative angle. The most common unit for measure of angles is degrees. 30 degrees, 60 degrees, 90 degrees, 180 degrees, 360 degrees, 540 degrees, and all those various different types of degree measures. And that's the most common that we use. A complete rotation around a ray is 360 degrees. You know that. I mean, you hear skateboarders or skiers doing 360s or 720s or 1440s or whatever. That's a complete rotation kind of around that circle. Obviously, if you're writing down these definitions, I'm going through them rather quickly. There's a pause button that you could press if needed. 1/360 of a one 1/360 of a complete rotation gives you an angle whose measure is 1 degree. Okay. So we've got acute, right, and obtuse angles and straight angles as well. Anything less than 90 is acute. At 90 is a right. Anything more than 90 but less than 180 is obtuse. And then you've got a straight angle that's 180 degrees. Again, kind of those basic geometry terms that you've learned kind of along the way. And again, if you have to press pause, press pause. So finding complementary. So in this example, we're going to find the complement and supplement of an angle. For a 40-degree angle, we're going to find the measure of its complement, and we're going to find the measure of its supplement. To find the measure of a complement means two or more angles that add up to 90 degrees. So complement is 90 degrees. So when you're finding the complement of an angle, you're going to take 90 minus whatever angle that they give you. And that's going to be its complement. So in this case, it's 90 minus 40. It equals 50. Supplement means 180. So to find the supplement of an angle, you're going to take 180 minus 40, in this case, to get its supplement. Okay, so you take complement is 90, supplement is 180. Complement 90, supplement 180. 90 minus your angle to get the complement, 180 minus 40 to get the supplement, or 140 minus your angle. So then let's say we're doing a little bit different and saying, okay, find the measure of the complementary, and in this case it's asking us to find the measure of each angle. Well, we've got two angles that form a right angle. So when you have two angles that form a right angle, it means that those two angles, since they form a right angle, have to add up to 90 degrees. It's kind of that angle addition postulate. So you get 9x equals 90, you get x equals 10. Now that we know the measure of x, we can substitute it back in, get that this is 60, and get this is 30. So there are the measures of those angles. And it's just asking you to find the measures of the angles in this case. You don't really have to do the supplement. Just understand that complement means 90, and that's what that little box down there means as well. Okay? Combine my terms, divide, put it in there, and so on and so forth. Okay? So in this case, find the measure of each angle, and I kind of put the answer up there already. But you've got 4x and 6x, and they form that straight line. So these are supplementary to each other. So 4x plus 6x in this case has to be 180. So 10x equals 180, x equals 18. So that gives us 4 times 18 is 72, and 6 times 18 is 108. Okay, again, basic geometry, angle addition postulate. In this case, those two angles form a straight line, so they have to add up to 180 degrees. And there's our solutions, just like we did it. Okay. The next thing we have to talk about is we have to talk about degrees, minutes, and seconds. So we're kind of talking about the clock now. So something we have to keep in mind. This represents 1 minute. So 1 minute is equivalent to 1/60th of a degree. Okay. And then 60 minutes is equal to 1 degree. Okay, so you're going to want to have this conversion down, because a lot of the things that we're going to do in this is we are going to do, conversions with this. So 1 degree is 1 minute is 1/60th a degree, and 60 minutes is equal to 1 degree. Okay, 1 second. So the 2 marks means second. 1 second is 1/60th of a minute, which is 1/3600th of a degree. Okay, and then 60 seconds is equal to 1 minute. I mean, obviously you know that. Okay, that's not that bad. Okay, so we're going to perform some calculations. We're going to take 51 degrees and 29 minutes and add to it 32 degrees and 46 minutes. So we're going to add these two things together. So when we add them together, you just kind of add the degrees and the minutes separately. So we've got 51 degrees, 32 minutes. 51 degrees, 29 minutes, plus 32 degrees, 46 minutes. That gives us 83 degrees and 75 minutes. When you think about kind of that 75 minutes, do we have 75 minutes? Not really. 75 minutes gives us an additional degree. So the 83 is going to become 84. And you think about minutes as on the time clock is just 60. So you've gone around once, so we can add a degree on there. That's why it becomes 84. And then we've got an additional 50 minutes. It goes this way. We've got an additional 15 minutes left. So when you add those two together, you're going to get 84 degrees and 15 minutes. Okay. Anytime you get over that barrier of that 60, you have to be a little bit careful. Okay. Same thing when you're subtracting. You gotta be a little bit careful with this. When you're subtracting 90 minutes, you can't really write that as 90 minutes. You have to do the conversion to 89 degrees and 60 minutes. Okay? Because we're not dealing with hundreds anymore. Okay, so 89 degrees, 60 minutes is the same thing as 90 degrees. Then we can just go ahead and subtract from there and get 16 degrees, 49 minutes. So you gotta be a little bit careful when you're doing these, especially when you're subtracting a little bit. Subtraction can be a little bit messed up, so to say. So if I give you something like 80 degrees minus 62 degrees, 10 minutes, that's going to be the same as 79 degrees and 60 minutes minus 62 degrees, 10 minutes. So you end up with 17 degrees, 50 minutes. And again, kind of think about all those clock things and kind of how clocks work is really what you're doing with minutes and seconds. Okay. So now let's say we want to convert 74 degrees, 8 minutes, 14 seconds to decimal degrees to the nearest hundredth. Okay, so we've got 74 degrees, 8 minutes, 14 seconds. This is where we're going to need those conversions that we talked about earlier. The degrees stays the same, doesn't change at all. Then you're going to take the minutes and you're going to write that over 60 and add that to it. Plus, then you're going to take the seconds and put that over 3,600. That's where kind of that conversions that you should have wrote down earlier takes place. If you didn't write them down, go back and do that. And then you break your calculator out and take 8 divided by 60, get that number. Take 14 divided by 3,600, get that number. Add them all together, and you're good to go. Okay. So now let's go the other way. Let's convert 34.817 degrees into minutes. So we're going to go the other way with it. Okay, so we're going to go and rewrite it as 34 degrees plus 0.817 degrees. Still adds up to be the same. Okay, now we're going to take that times minutes because we would rather take it we're going to change it to minutes. So we're going to take that times 60, and then you're going to get a result of 49.02 minutes. Okay, so now you still got that 0.02. So since we've got that 0.02, we've got to calculate that and change that into seconds. So we're going to multiply that by 60 as well. You get 34 degrees, 49 minutes, 1.2 seconds when you're doing this. Okay. So I'm going to, I know it's probably going to go on and not give us another one. It's going to talk about in standard position here, but we're going to go back and I'm going to use this page, but we're just going to do a couple more. So let's go ahead and take 64 degrees, 7 minutes, and 10 seconds. And we're going to convert that to degrees. To the nearest, we're going to convert that minutes to degrees to the nearest thousandth. Okay, so we're going from degrees, we're going from minutes to degrees. Okay, so again, we got to kind of use our conversion there. Okay, so we're going to leave the 64 degrees alone. We're going to add to that 7 minutes over 60 seconds plus 10 over 3,600. I'm going to break out the calculator. 7 divided by 60. So that's 64 plus 0.1166 plus 10 divided by 3,600 is 0.00277. Add all those things together, and you get 64 degrees 12, 64.12 degrees. I can't back up. And that's what that is to degrees, tens, hundreds. I won't do a one more, but whatever. Okay, so that's, again, converting it to degrees. When we convert it to minutes, let's do another one. Let's go 40.318 degrees, and we're going to change it to minutes. Okay, so bring the calculations up there. So it's 40 plus 0.318. So we're going to take 40 plus 0.318. We're going to take that times 60. So 40, well, we'll just do the 0.318 times 60. So this is 40 plus 19.08. So that gives me 40 plus 19 plus 0.08. We're going to take that times 60. And that gives me 4.8. So we've got 40 degrees, 19 minutes, and 4.8 seconds. Okay, so just keep those conversions in mind. Anytime you're going to minutes, you're multiplying by 60. Anytime you're going... All right, I'm back. Good class. So let's look at now how we go about graphing or plotting or putting a graph in or an angle in what we call standard position. So an angle in standard position is if the vertex is at the origin, or turn that down or I'm going to get censored. An angle in standard position if its vertex is the origin and the initial side is along the x-axis. Okay, so we call this an angle that's in standard position. Our initial side is right here along that x-axis, and then it opens up in that direction, and this is again our terminal side, which we've talked about already. A couple things remember to keep in mind about the coordinate plane. This is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Geez, nice 4. Quadrant 4 down there. And you don't have to, I mean, you can go either direction when you're talking about an angle being in standard position. You can go either have a positive angle or you could have a negative angle, whether you go counterclockwise or clockwise. You can create that. And just again, a couple other things to remember. Remember, it's 90 degrees, 180 degrees, 270 degrees, and 360 degrees, kind of around this whole thing in the coordinate plane. So, I mean, you could be asked to graph a 95-degree angle and just give an approximation where a 95-degree angle is, and those different types of things with this. And then again, just what I said, the x and the y axes, you got your 90, 180, 270, and if you go in the negative direction, it's negative 90, negative 2, negative 180, negative 270, negative 360, and so on and so forth. So we can create then different angles within here. So in this case, what they did is they're talking about, they drew a 60-degree angle. So we've got a 60-degree angle sitting right there, and you draw that 60-degree angle by going up about 60 degrees. And then what this slide is talking about is it's talking about coterminal angles. And coterminal angles are angles that have the same terminal spot. So essentially, if you've got a 360-degree angle, or I'm sorry, if you have a 60-degree angle, a coterminal angle to that, you're going to either add 360 degrees or you could subtract 360 degrees, because you think about it, you're starting here and you're going to here. A coterminal angle, you're going to rotate 360 degrees and it's going to end in the same spot. Or you're going to go the other direction and it's going to end in the same spot. And that's what coterminal means. They have the same terminal side. And you get to that terminal side by either adding 360 degrees or subtracting 360 degrees from them. So in this example, it says, find an angle of least possible positive measure. Okay, so when it's talking about least positive measure, it means that the angle needs to be between 360 degrees and 0. So with this, if we start with 908, obviously we've got to go down. So I could sit here and draw a 908 degree angle. There's 360. There's 720. There's 810. The next one's going to be 900, so it's just short of 900. So there's a 908 degree angle. Now the coterminal angle, but I've got to get it to be less. I mean, I'm just going the opposite direction, so I'm subtracting 360. If I go 908 minus 360, I get 548, and I haven't hit between 0 and 360 again, so I'm going to subtract another 360 from that, and I get 188 degrees. So those are coterminal angles to each other. And I guess 908, I messed it up, is over there. Sorry, that's 900. Yeah, that'd be 82, whatever. So there is our coterminal angle to that. Okay, so you just subtract 360 as many times as you need to. And you get a 188 degree angle, which is exactly what I said. Okay, so those are coterminal. The next one says find the angle of least positive measure of a coterminal with negative 75. So if we look at negative 75 goes in that direction, so it's going to be right there. I need it to be positive, so I need to come around in this direction. So I'm going to go negative 75 plus 360, and you get 285. So 285 degrees is what this angle right here would be. That's a coterminal angle with that one. Okay? And you can see that's what they did as well. Okay? And again, here's just another one. Find the angle of least positive measure. Coterminal is negative 800. I'm not going to do this one. I'll just click through it. They did it, they did the 3 times, but whatever. You just keep adding 360 until you get to it, and you get 280 degrees. So coterminal angles, this says find an expression. We're not going to worry about finding the expressions with these. Angle and coterminal angles, we're not going to worry about that as much either. So there is section 14.1. And again, we looked at basic terminology, degree measure, standard position, and we talked about coterminal angles. Assignment in this one is a little bit longer, but some of them are really pretty quick to do the assignment. I think the average assignment thing should take about 20 minutes or somewhere in there. So go ahead, get working on 14.1. We'll do 14.2 tomorrow, which I think is probably starting basic trig function.